In this episode, we begin with a topic that most people use every day without thinking much about it, even though it sits at the center of how modern organizations work. Businesses rarely rely on one isolated application that does everything by itself. Instead, they depend on many systems exchanging information, requests, updates, and results so that employees, customers, vendors, and managers can keep moving through their work without interruption. That connection point between systems is what we call a system interface, and it matters enormously in the Certified Information Systems Auditor (CISA) world because data and control often break down not inside a single system, but between systems that are supposed to cooperate. A beginner can think of an interface as the handoff area where one system passes something to another system and expects that handoff to be correct, timely, secure, and understandable. If that handoff fails, even good systems can produce bad business outcomes. Orders may disappear, reports may be inaccurate, approvals may not reach the right place, and people may lose trust in the technology even when the deeper problem is not the application itself, but the connection between applications. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A system interface is the method or pathway through which one system communicates with another system. That communication can involve sending data, receiving data, requesting a service, confirming a transaction, or triggering some later action somewhere else in the environment. Beginners sometimes imagine an interface as a visible screen where two tools appear connected, but that is only one small part of the picture. In practice, interfaces often operate behind the scenes, passing information between applications, databases, devices, and services without direct user involvement at the moment the exchange happens. A payroll system may send information to a bank file process. A sales application may transmit orders to inventory and shipping systems, or a human resources information system, HRIS, may update employee status in identity management tools. The business sees a process moving forward, but underneath that process, interfaces are doing the work of carrying meaning from one place to another. That is why interfaces are not just technical plumbing. They are operational pathways that help separate systems behave like one coordinated business environment. One reason interfaces matter so much is that organizations grow in layers over time rather than by replacing everything at once. A company may adopt a finance platform in one period, a customer system in another, a reporting solution later, and then newer cloud services as business needs change. Each of those systems may be useful on its own, but the real business value often depends on whether they can share information in reliable ways. If the sales system knows a customer placed an order, but the billing system never receives that update, the business experiences a serious disconnect even though both systems may be functioning separately. A beginner should understand that most business failure in this area is not about whether data exists somewhere. It is about whether the right data reaches the right destination at the right time and in the right form. Interfaces make that possible. When they work well, organizations gain speed, consistency, and fewer manual steps. When they work poorly, people start rekeying data, creating spreadsheets, calling support, or inventing workarounds that weaken both efficiency and control. Interfaces come in different forms, and that variety matters because each style creates different strengths, limits, and risks. Some interfaces are file-based, where one system creates a file and another system later reads and processes it. Some are message-based, where systems exchange structured information more directly as events happen. Others use an application programming interface, API, where one system formally requests a service or piece of data from another in a defined way. A beginner does not need deep engineering knowledge to understand the main point. Different interfaces reflect different business needs. Some are designed for speed and immediate response, while others are built for large volume background processing that happens on a schedule. What matters in CISA thinking is not memorizing every technical model, but understanding that the interface design should fit the business purpose and risk profile involved. A system that needs near-immediate updates may be poorly served by a slow, delayed handoff, while a high-volume overnight process may not need the same style as a user-facing transaction. Another important distinction is between real-time and batch interfaces, because they shape how quickly systems exchange information and how the business experiences that exchange. A real-time interface sends or retrieves information during the active transaction, so the result may appear immediately to the user or connected process. This can be very useful when fast response matters, such as checking account status, validating customer details, or confirming whether a product is available. A batch interface, by contrast, groups information together and transfers it later, often on a schedule, such as at the end of the hour, end of the day, or another processing window. Beginners should see this as a timing decision with business consequences. Real-time communication can improve freshness and responsiveness, but it can also create tighter dependencies between systems. Batch processing can be efficient and easier to manage at scale, but it introduces delay and may allow problems to sit unnoticed until the next scheduled run. Neither model is automatically better. The key question is whether the timing of the interface supports the actual business need and control expectations. For any interface to work well, the systems involved need a shared understanding of what the data means and how it should be organized. This is one of the easiest points for new learners to underestimate because it sounds simple on the surface. If one system records a date in one format and another expects a different format, or if one system treats a field as optional while another treats it as required, the handoff can fail or produce misleading outcomes. A customer identifier, an account code, a product status, or a transaction amount all need consistent interpretation if the receiving system is going to use them correctly. This is why interface design involves more than just opening a communication path. It also involves defining data fields, expected formats, valid values, record structure, timing assumptions, and the business meaning behind the information being exchanged. An interface can be technically active and still be functionally weak if the sending and receiving systems do not agree on what the information represents. In audit terms, that becomes a data integrity risk, not merely a formatting inconvenience. Data integrity sits at the center of interface control because the whole point of an interface is to transfer usable information without losing meaning, completeness, or trust. When one system sends information to another, the organization needs confidence that the receiving side got the correct data, got all of it, and processed it in a way that matches business expectations. A beginner might think success simply means the interface ran without obvious error, but many real problems are subtler than that. An interface may complete and still send duplicate records, drop a small percentage of transactions, misread a code, or place a value into the wrong field. Those errors can quietly affect billing, reporting, inventory, user access, or compliance without causing an immediate dramatic failure. That is why organizations use validation, reconciliation, control totals, record counts, and exception handling to confirm interface results rather than blindly trusting the transfer. In a CISA mindset, the question is not just whether systems talk to each other. It is whether the conversation produced reliable business information that management can safely act upon. Error handling is especially important because interfaces do not operate in perfect conditions. Networks fail, source systems become unavailable, data values fall outside expected rules, timing changes unexpectedly, and downstream services may reject transactions. An interface that has no clear way to detect, report, and respond to these conditions becomes a hidden source of operational risk. Beginners sometimes assume an interface either works or does not work, but in real environments there are many partial failure states that are more dangerous than total failure. A complete stop may be noticed quickly, while a partial problem can continue long enough to contaminate reports, confuse users, or delay important activity. Strong interface management, therefore, includes logging, alerting, retries where appropriate, and procedures for investigating rejected or incomplete records. It also includes clear ownership, so someone is responsible for watching the interface and acting when problems appear. From an audit perspective, error handling shows whether the organization has treated interfaces as governed business processes or merely as background technical features that no one notices until the business starts asking why numbers no longer match. Security is another major concern because interfaces often move sensitive information and may connect systems with different levels of exposure or trust. An interface can carry customer data, employee information, financial records, operational details, or control-related transactions that should not be visible or alterable by the wrong parties. If the interface lacks proper authentication, authorization, encryption, or monitoring, the organization may create a weak point between otherwise well-controlled systems. A beginner can think of this like a locked building connected to another locked building by a poorly secured hallway. Each building may look safe on its own, yet the connection between them creates a path where risk can grow. Security around interfaces includes controlling who or what can send and receive data, protecting information while it is moving, validating that messages come from trusted sources, and maintaining logs that support accountability and investigation. For CISA, this matters because many control failures happen at boundaries. Interfaces are boundaries by nature, and boundaries are where organizations most need discipline, visibility, and clearly defined trust rules. Monitoring and performance also deserve attention because an interface may be essential to the business even when users do not see it directly. If a critical interface slows down, backs up, or fails intermittently, the business may experience delayed updates, inaccurate dashboards, missed approvals, or transactions stuck in the wrong status. Monitoring helps the organization detect these problems before they spread too far. This may involve checking whether messages are being processed on time, whether error rates have changed, whether queue volumes are growing, or whether downstream systems are receiving expected results. Beginners should understand that a quiet interface is not automatically a healthy interface. Silence can mean success, but it can also mean that no one is watching closely enough to notice trouble. Performance matters too because interfaces often support chains of dependency. If one connection slows significantly, the delay can ripple across several business processes. In audit language, good monitoring provides evidence that the organization is not simply assuming the interface is fine. It is actively verifying that essential system-to-system communication remains stable, timely, and within expected conditions. Change management is closely tied to interfaces because changes in one system often affect the other systems connected to it. A field added in one application, a format changed in a file, an updated business rule, or a timing adjustment can all break an interface if related changes are not coordinated properly. This is one of the reasons interfaces can create surprising problems during system upgrades or implementations. A beginner may focus on the system receiving the new feature and forget that the connected systems must still understand the results. In practice, interface changes should be documented, tested, approved, and communicated across the groups that rely on them. Testing matters especially because an interface that works in a simple scenario may behave differently under real production volume, unusual data values, or revised sequencing. Auditors care about this because interfaces are shared points of dependency. When one team changes them casually, the business can suffer far beyond that team's own application. A controlled change process helps prevent surprises by treating interface design as a business dependency rather than a local technical preference. Documentation is another foundational control because interfaces are easy to misunderstand when knowledge lives only in the minds of a few experienced people. The organization should know what the interface does, what systems it connects, what data it moves, what schedule or trigger it follows, what controls apply, what errors can occur, and who owns the response process. Without that knowledge, support becomes fragile. If the one person who understands a critical interface is unavailable, the organization may struggle to diagnose failures, approve changes, or even explain how an essential process works. Beginners should see documentation not as a bureaucratic exercise, but as a way of preserving operational truth. Interfaces are often invisible until something goes wrong, which means good records are essential during incident response, audits, upgrades, and recovery planning. A CIS, a perspective values documentation because evidence and continuity depend on it. If the organization cannot describe its interfaces clearly, it is harder to claim that those interfaces are under effective control. A common misconception is that interfaces are purely technical details with little business meaning. In reality, interfaces often determine whether business processes feel smooth or frustrating, accurate or unreliable, controlled, or chaotic. Another misconception is that once an interface is built, it will keep working indefinitely unless a major outage occurs. The truth is that interfaces live in changing environments. Systems get upgraded, business rules evolve, data volumes grow, vendors change formats, and security expectations rise. There is also a tendency to assume that if users are not complaining, the interfaces must be fine. Yet many interface problems do not become visible immediately. They appear later as reconciliation breaks, delayed records, missing notifications, or reports that no longer agree across departments. For beginners, the key lesson is that interface health must be actively managed rather than casually assumed. Interfaces are not minor connectors sitting outside business importance. They are part of the operating fabric of the organization, and weak attention to them often produces problems that look mysterious until someone traces the issue back to the system boundary. From the auditor's perspective, system interfaces are examined through the lens of business risk, control design, evidence, and operational reliability. The auditor wants to know what critical interfaces exist, what information they carry, how they are secured, how they are monitored, how errors are handled, how changes are approved, and whether the organization can show that the interface results are complete and accurate. The goal is not to admire technical complexity or demand that every interface look the same. The goal is to determine whether the organization understands the dependencies it has created and whether it governs those dependencies well enough to support the business. If critical interfaces rely on informal knowledge, weak monitoring, poor validation, or unclear ownership, management may be far less protected than it believes. That is exactly the kind of gap CISA asks learners to notice. Interfaces matter because business processes increasingly depend on systems that are connected, and connected systems require control that is just as deliberate as the control inside the systems themselves. The central idea should feel clear. System interfaces are the pathways that allow separate systems to exchange information and behave like parts of one larger business operation. They help organizations avoid duplicate effort, support timely decisions, and keep processes moving across applications, teams, and services. At the same time, they introduce important responsibilities around data meaning, validation, security, monitoring, error handling, documentation, and change control. When interfaces are well designed and well governed, the business gains speed, consistency, and a stronger flow of trusted information. When interfaces are weak or poorly understood, even strong applications can produce confusion, delays, and control failure because the handoffs between systems break down. For exam preparation, remember the main lesson that boundaries matter. A CISA mindset does not stop at asking whether each system works on its own. It asks whether the connections between systems are accurate, secure, controlled, and dependable enough to support real business activity every single day.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.